the next person I want to fast forward to is a group of people, and those are the Mythbusters. And the reason I add the Mythbusters here, not because they're scientists, but they're modern day people using the scientific method. And so they'll answer many questions, but they answer those questions by developing first a hypothesis and then testing it. And they go out of their way to make sure that they're truly answering the question. So let's get into the scientific method. Scientific method was used by famous scientists. This one right here would be Isaac Newton. This one would be Charles Darwin. And this one right here was Niels Bohr. But they all use essentially this same method. And it always begins with a question. And so first of all, you start with what question do you want to answer? And so an example we could say right here is, let's say we have a plant, and that plant's growing. And we're going to play music for it, and we're going to play different types of music. And so maybe our question is, what type of music is actually going to make that plant grow best? So now we make a hypothesis. Maybe I'm of the mind that country music is going to make that plant grow fastest. And so that would be my hypothesis. Now we sometimes refer to as a hypothesis as an educated guess, but in scientists that's kind of a misnomer. It's not so much a guess as we know what's going to happen, we just have to prove it. Doesn't mean that our hypothesis is always correct, but we start with a hypothesis, which is this idea of what we think might happen. Next up is an independent variable, and so in an experiment the question will always tell you what the two variables are. And so listen carefully as I say that. I want to determine how the type of music affects plant growth. I don't know if you heard that, but there are two variables inside there. One was the type of music, and the other one is plant growth. And so if we go to independent variable, the way that I talk about this in class is the independent variable is the variable that I change. And so I change the independent variable. It's the one thing that I manipulate, and so that's that first variable in an experiment. The dependent variable then is a resulting variable. In other words, it results as an action of the independent variable. So if we go back to that question again, how does music affect plant growth? What's the independent variable? It's going to be the type of music that I play. What's the dependent variable? That's going to be plant growth. So what do we got down here? What are control variables? Those are everything that we keep the same. And so in this experiment, what are some things that we'd want to keep the same? Well, the species of plant would be one thing, maybe the amount of light it gets, the amount of water it gets, the nutrients it gets, the volume of the music, the amount of time that we play the music. And so those are all going to be the control variables, everything that we keep the same. And the trick is, if we don't control all the variables, in other words, if we have a few variables that change, not only the independent variable, then we can never know if we actually show that that independent variable has any effect on it. Okay, let's go to the next ones then. So what do we do next then? So this is a great picture right here. This is actually Einstein, and this in the background is another really famous astronomer. His name is Edwin Hubble, and so the Hubble Space Telescope is named after him. And what he was famous for was measuring the redshift in the universe, this idea that the universe is always expanding. Einstein doubted that and eventually said it was the biggest mistake that he ever made. So let's go to the next group then. What's a control group? So thinking back to that experiment with the plant, well, not only would we have one group that we are actually taking those plants and playing music for, but in a totally different room, we're going to have another group of plants, and those plants in the other room are going to receive no music at all. And so that the control group sometimes seems counterintuitive, but what is the control group? It's another group of plants that we're not exposing music to. Why would we do that? Well, we want to make sure that it's really the music that is affecting the plants, and it could be something else. And so if we see differences between these groups and the control group and the other one, then we can say that that's accounted to by the music. Next, we collect data. Data usually is collected in a data table, but it's always organized in a graph. When you do a graph, a thing to remember is that the independent variable will always go on the bottom, and the dependent variable is going to go on the side. If we're doing plant growth, maybe that's going to be a bar graph, where we've got independent variable are the types of music, and we put those on the side, and the dependent variable is going to be amount of plant growth. Or maybe it's going to be a graph like this where we're changing something, maybe the volume of the music over time, and we're looking at plant growth. It should say plant growth, and we're getting a graph that maybe looks like that. It's getting a little bit messy. Okay, so what is our conclusion? Our conclusion is going to address that question. And so conclusion is looking back at the question and saying, hey, is our hypothesis correct or is it incorrect? The next thing you have to do as far as science goes is you have an obligation to publish the results of your experiment. And we do those in primary research. We do those, in some kind of a scientific journal. And so when Watson and Crick discovered the structure of DNA, the first thing they did is they wrote it up in an article in Nature. And what that allows other scientists to do is to repeat their experiment, and that's how science builds itself. And so if you've ever wondered how a science book is made, a science book is made by scientists. And those scientists collect data, and that science is tested by other scientists over and over and over again, and eventually we have a truth. And that's what science is, and it's a lot different from other disciplines that you have. The nice thing about science is that other scientists are always trying to prove other scientists wrong. And so by doing that, it's this wonderful check and balance, and we eventually arrive at this wonderful truth, thanks to the scientific method. So that's scientific method, and I hope that's helpful.